Okay, hi guys. Sorry that I'm not here today. So I thought I would make you a quick video just trying to explain what today's note is all about. So as I'm going through this video, please feel free to pause, copy things down, practice some of the calculations as we're going along. And then you're welcome to play it as many times as you need to in order to get a better understanding of what we will be doing in today's class. So yesterday's topic was the empirical formula, and remember that the empirical formula is just the molecular formula reduced, so it's the molecular formula in lowest terms. But the molecular formula is so important because two compounds can have the same empirical formula, but they can have very different chemical properties, and they can behave very differently in chemical reactions. So finding the molecular formula of an unknown compound is actually really important. It's important in pharmaceutical research because when we're making new drugs, we want to make sure that we have the right chemical formula for what we've just created. It's important for environmental toxicology, so looking for what kind of chemical compounds are found maybe in water or air samples. And then in forensics, if we were to find an unknown substance, we would need to be able to figure out its chemical formula so that we could identify it. So today we're going to be calculating something called the molecular multiplier, where basically we're looking at the ratio of the molar mass that would be coming from a mass spectrometer. So the mass spectrometer, you're going to go ahead and read on page 281 in your textbook. That's going to be the first part of your homework today to figure out what this instrument is. And when we get back, or when I get back, I will explain this a little bit further. And then we'll be taking that molar mass and dividing it by the empirical mass. So let's jump into a problem. So in example number 1, it says a compound with the empirical formula CH has a molar mass of 78.11 grams per mole. What is the molecular formula? So the very first thing we want to do is we want to calculate the molar mass of this empirical formula. So just CH. So looking at my periodic table, carbon has a molar mass of 12.011, hydrogen 1.008. Add these up and my molar mass is 13.019 grams per mole. I'm going to go ahead and calculate this molecular multiplier. And so what it is you take the molar mass that was given in the problem, and that's the molar mass of the actual compound found by using that mass spectrometer, and we're going to divide that by the empirical mass that we just calculated. So this number up here, this is the molar mass. And what we just calculated here is my empirical mass. So 78.11 grams per mole divided by 13.019 grams per mole. Throw that into my calculator and I got 6. This number, if we've done the calculations correctly, should be very close to a whole number. And why it should be very close to a whole number is this is the number that we're going to be multiplying the empirical formula by in order to get the molecular formula. So my empirical formula was CH. And we just found out that my multiplier is going to be 6. So if I just write in, I'm just going to float in little ones here just so you can see what I'm doing with the numbers. And I'm going to be multiplying each of those subscripts by 6. So this one and this one. So that means that the molecular formula is C6H6. So this is the new step that we're going to be adding on to the end of last day's problems. So what we're going to do now is I'm going to ask that the supply teacher just pause the video. You are going to start with example number 2, and you are going to get all the way down to the empirical formula. So you're going to find the empirical formula first. So I'm just going to say number 1, find the empirical formula. And then you're going to go and try the new part, which is to find the molecular formula. So one thing that you're going to notice in tonight's homework is you've got this extra number in your homework questions. Okay, so we're just going to stop the video right now, give you a chance to try to calculate this on your own, and then we'll put up the final answer so that you can check your work or just go through it. Okay, thanks.